Okay, last time we were on the heading determination of polarity of a solenoid. This was the last title we did. This chapter is magnetism. First of all, recall me what are the three chapters of our O level are merging here? What are the three chapters of O level are merging here? Magnetism, electromagnetism, and electromagnetic induction. There are three chapters merging in this chapter. Achha, now recall me what is a solenoid. Solenoid is a coiled wire. Solenoid is a coiled wire. So when electric current passes through a solenoid, it produces a semi-linear magnetic field. Now, what is the meaning of polarity? North pole and south pole. The first thing which they like the most, the first thing they want people to appreciate, they always say they use the word appreciate. They want people to memorize this so-called great name. So what's the name of the rule which is applied here for the polarity? Fleming's right hand rule. Second approach to determine the polarity is magnetic compass, which is a laboratory approach. And the third one is looking at the direction of current, you can tell the direction of polarity. Now you have to copy, you have to give the heading is already given, I think so. Heading was given, right? Heading was already given. So now after giving the heading, write under it polarity of a solenoid. Number one, Fleming's right hand rule. Write under it. Number one, Fleming's right hand rule. Number two, magnetic compass. The second way to determine the polarity. The second way to determine polarity is second way to determine polarity was magnetic compass. And what is the third way? Direction of electric current. What we are determining? We are determining the polarity, North Pole or South Pole. Now let us roll over this list. I hope you people can recall this from O level, a very famous diagram. Hold the solenoid in your right hand. If you have to hold it like this, thumb is pointing to the left. Look at the diagram. This is the thumb position. This is the thumb position, and thumb position shows north. Look at the folded fingers. The folded fingers show the direction of current. So this is called Fleming's right hand grip rule. In this rule, now you are showing the direction of current and you will get the direction of north. So if you hold the solenoid like this, look at the thumb, left hand side. When you hold it like this, thumb is pointing to the right, north will be to the right side. This rule is going to be applied specifically for a solenoid. So after giving the list, okay, now you have to write under it number one, give a side heading number one. And after putting number one, like you put number one like this, and then write under it, hold the solenoid in your right hand. Hold the solenoid in your right hand. Hold the solenoid in your right hand such that hold the solenoid in your right hand such that the fingers are folded such that the fingers are folded in the direction of current such that the fingers are folded in the direction of current, comma, the thumb will point out in the direction of north. The thumb will point out in the direction of current. Oh, sorry, in the direction of north. In the direction of north. So now let me know that in our O level, AS level, how we determine the direction of current. This is the diagram. We have a plus and we have a minus. How we remember, how we recall the direction of current? Current always travels from plus to conventional current. Conventional current is always from positive to negative. So I have closed that circuit. I have closed the circuit. Okay, now after giving the statement, copy down this diagram. After giving that statement, copy this diagram neatly. Copy this diagram neatly. Acha, can you people recall me one more thing before we go? Why there is an iron core? It is? थोड़ा सा लाउड वहां कहाँ बैठी हुई हो शुक्र है दीवार है वहां से आगे वरना तुम और पीछे जाती हाँ बोलो नहीं बैठी रहो बट गिव यू कैन स्पीक लाउड ना soft iron, does it support magnetism? Ahmed, soft iron, what's the purpose of iron core? Iron core enhances magnetism. So now you have to copy this. Walaikum assalam. And everyone is not. Good entry, good entry. Please sit down. Forget what they are saying now. Ahmed, recording के बाद जो है ना okay, direction of current is from plus to minus. Current is directed from plus to minus. Now look at this diagram. Look at this diagram. You people have to put Fleming's right hand rule on this diagram and tell me where would be the north, left side, right side. Right hand rakho like this. Right hand rule ऐसे लगाना है. One option like this, one option like this. How we determine the current direction? The direction of current, will it be in the direction of the fingers? Look at the right hand rule. The fingers will be pointing in the direction of current. So now, how should I put my fingers here? Should I put it like this, option 1, or this, option 2? Okay. When I put it like this, north will be on the right side. Like O level, he will ask, mark the direction of current. Mark the direction of current. He will ask the direction of magnetism. Then he will be very excited to ask how you come to know that north is here. You have to write Fleming's and then he will be very happy because he wants to hear the name Fleming's right hand grip rule. Okay, now on the same diagram, copy north and south also. North and south. Right hand. The field north is south here. No, there is no field marked here. I haven't marked any field. देखो ना रख के दिखाओ उसको अहमद how you put your right hand. ऐसे करके रखेंगे ना कि ये देखो
ये करंट है, ये 4 उंगलियां करंट। हाँ तो फील्ड की डायरेक्शन होगी ना।
Look at this.
डायरेक्शन तो किसी से कहीं फील्ड की
Feel I haven't shown. There is a little confusion. I think Adil is facing. Acha, let's move forward. North and south. Okay. Then you have to go back on a previous diagram. Everyone, please pay attention. Go back on that previous class diagram. In that diagram, the diagram is already there. You have to go back last class and look for this diagram. Mark the arrow. This is what Adil was asking or discussing. Now the arrows are not to south outside the solenoid. And what is the direction of the arrows inside the solenoid? South to north. So now you have to go back in the previous diagram, neatly introduce arrows, make sure the lines do not touch each other. Quickly mark the arrows. Ahmed, mark the arrows. Diagram. Where is the diagram? कर दिया अच्छा we are doing the chapter magnetic field. It's a long chapter. It covers our O-level memory of magnetism, electromagnetism, and electromagnetic induction. Right now, what are we doing? What is this section called as? Electromagnetism. What is electromagnetism? Magnetism due to current. Now, if we reverse the polarity of current, look at this diagram. Can you people notice the direction of current? I'm going to reverse. If I reverse the current, the polarity will change. Now, north is on the left side. If I reverse the polarity and I get a different polarity of current, magnetism reverses. What if I use alternating current? If I use alternating current, what will happen? Look, why the polarity is changing? Good. So now you have to write under this R point, जो आपने अभी लिखा, you have to write under it that if AC voltage is applied, if an AC voltage is applied across the solenoid, if an AC voltage is applied across the solenoid, if an AC voltage is applied across the solenoid, across the solenoid, the polarity of the electromagnet keeps on switching. The polarity of the electromagnet will keep on switching. The polarity of the electromagnet will keep on switching. Will keep on switching. Now I bring in another important concept from my O-level, and I explained last time that what I am doing, this is a very important chapter. Sometimes it gives 2 questions in our paper 4. Now what I'm doing, I'm connecting my dots from O-level and I'm putting my A2 after that in every topic. Like solenoid, I have picked from O-level. I didn't leave a gap. Okay, fine, go and read solenoid or any video or any document, because I believe that's always just like a self-illusion that you will go and read. No one will do that. Now I'm putting a very important concept from O level. That was the concept of number of turns. What was the concept of number of turns? Greater the number of turns, greater the strength of the electromagnet. Look at this. This is an electromagnet. Now, if I increase the number of turns, then will I get a stronger electromagnet? Good. So now you have to write after this concept, you have to write next line. In the next line, write under it, greater the number of turns, greater the number of turns, greater the strength of the electromagnet. Greater the number of turns, greater the strength of the electromagnet. Now comes in our A2 contribution. In a solenoid, we have a formula P is equal to mu naught Ni. This formula was discussed in our yesterday class also. What the letter B stands for? Magnetic field strength. The letter N, small n, number of turns, mu naught, permeability of free space. What was the unit of mu naught? Henry per meter. What letter I stands for? What is the what is the constant value of mu naught? 4 pi into 10 to the power. Good. Up, you have to put this formula. No need to copy the diagram again. Go back in this diagram and put this formula there. Already this formula was there in yesterday class also, but it is coming again to show that P is proportional to N. Copy this. B is equal to mu naught Ni. Now let's move forward. B is equal to mu naught Ni. You can also determine the polarity of an electromagnet by looking at the current. What is the theme here? If you look from one side and you find the current is clockwise, if you look at one side of the solenoid, suppose this is the solenoid, huh? This is the solenoid. Do not look from this side, look it from this view. So if you see the current is clockwise, if the current is clockwise, you will see that what pole will be formed there? South pole. Achha, if you look at the solenoid like this, you see the current and you identify that the current is anti-clockwise, then what type of pole will be there? North pole. This is my next concept for today, that polarity can also be determined by looking at the current direction. What is the ambiguity about it? If I move it like this, if I move it like this, it is for me clockwise, but for the people in front of me, if I move it like this is the problem in this method. Now, change the line, take a new line and write under it, polarity of an electromagnet can also be determined. Polarity means north pole, south pole. Polarity of an electromagnet can also be determined. Polarity of an electromagnet can also be determined by looking at the direction of current at a corner. By looking at the direction of current at the corner. Looking at the direction of current at the corner. Okay, now you have to copy this. Now, comes to the title which I was asking, and two people answered on this concept: effect of a soft iron core inside a solenoid. This concept is again connected with our O level. In our O level, we studied that if you insert an iron core, look at the left hand side, there is nothing inside the solenoid, it's a hollow one, and it has an iron core, right and left, right and left, which is a stronger electromagnet. Right one, left one. Right one. Good cue. Why? In case of iron core, can you see the lines are highly concentrated? And without the solenoid, what is the difference in the field? What's the difference? Less concentrated. Good. And in our O level, this concept was called as shielding effect. So now change the line, and write under it, presence of an iron core, presence of an iron core, presence of an iron core increases the concentration of flux, increases the concentration of flux, increases the concentration of flux. This is called shielding effect. This is called shielding effect. Due to this effect, this is called shielding effect. Due to this effect, due to this effect, due to this effect, the strength of the electromagnet increases. The strength of the electromagnet increases. Now let's have a memory test. Why iron? Why not something else? Why not aluminum, gold, silver? Why iron? Iron magnetized हो जाता है. Anyone else? She will tell. हाँ बताओ. Iron. There are two names in our O level, iron and steel. Both can be used here. But आदिल को याद भी आ गया कि iron was a temporary magnet. Why iron was used? Because iron becomes a magnet. Aluminum and these other metals, they do not get magnetized. So can we say when we put iron inside the solenoid, like here, when we put iron in the solenoid, there is a magnet inside the solenoid also. So magnetism will be enhanced. So why iron? Because iron is a magnetic material. Now quickly recall, I had posted this on the group also. What was the relation with iron versus steel? What was the relation for iron and steel? Iron is a temporary magnet. It magnetizes, demagnetizes. What about steel? Steel becomes a permanent magnet. So if I want to put a door catcher, it would be from steel. And if I want to install a RAM in my computer, it should be iron. Why? It will become magnetized, and when you switch it off, then it will demagnetize. Good. Now let us summarize our whole discussion here in this article by now today. Factors affecting the strength of the electromagnet, one by one. What is the first factor? Number of turns. And what is the second factor? Amount of current, presence of. What is this last factor? What resistance has to do in this topic? Does resistance oppose current? Okay, good. So now you have to copy, everyone has to copy this sheet. Now, give a new heading, give a space of 2 lines. We are starting our next title. This was not in our O level. This is an A level typical topic, but some people might have studied in O level. But it is a topic here. The title is a circular coil. Give the heading circular coil. Now, first recall that circular coil means what? Look, this is a straight wire. For example, I take it as a wire. Now, this is a straight wire. If I make it a loop like this, I fold it like this, now it is called a circular wire. So, what is the main concept? I have a straight wire. This is a straight wire. I bend the wire in a loop. Now, this loop is called circular coil. What is a circular coil? You have a cardboard. From one side, the wire is going up. Same wire is coming down from the other side. Now, there are two sides of the wire. One side, we are creating a red field. Other, we are creating a green-blue field. Why the field directions are opposite? According to Fleming, right hand grip rule. Look at the direction. Here, the direction is clockwise, and here the direction is one side direction is clockwise, and other side the direction is anti-clockwise. Now you have to write under it a circular coil is a loop of wire. Circular coil is a loop of wire. Circular coil is a loop of wire. Now you have to copy this diagram neatly. Remember, the two lines should not cut each other. The field lines should not cut each other. You have to copy the formula. You have to copy the diagram. This is a circular coil. Now look at the formula. B is equal to mu naught Ni upon 2R. You have to tag the formula as given formula. It will be given. You are not supposed to memorize it. There are some formulas in our course, A2 course, which are always given. Now we move forward again. What is the value of mu naught? 4 pi into 10 is to power minus 7 Henry per meter. Now, this is a circular coil. Now, give the heading relay.
switch that. You switch English.
Mhm. Give the heading relay. Now, what was relay? It is basically a type of electromagnetic circuit which can bridge between two devices. Like, for example, how we start our, we move the key and the car engine starts. Now, the car ignition is directly starting the car, or there is a bridge between them. बैटरी स्पार्क करती है ना, और उसके आगे फिर इंजन का पार्ट होता है. सो रिले इज बेसिकली अ टाइप ऑफ ब्रिज. रिले इज एन electromagnetic switch that uses a small current to switch on or off a large current. So first let's write down the definition. A relay is an electromagnetic switch. Hello, she is awakened. क्या हुआ? A relay is an electromagnetic switch that uses a small current to switch on or off a large current. Now let us put some examples where you people can find this relay in action. Like you people might have noticed the automatic doors in our shopping malls. When they came here, people were very excited to see them. When you come close to them, the door automatically opens. This is a relay function. The central locking in our car, you press down one switch, all the locks are down. This is a relay. Have you, anyone observed the method in tall buildings, flats, offices, where the door is digitally locked? You announce yourself, you identify yourself, and someone press the button from inside, a buzz sound come and door opens. Anyone had an example of this? What example? Offices, the flats building. Similarly, the car ignition system, you move the key, you hear a spark sound, but that is a primary circuit. Circuit breaker is also an electromagnet. Now look at this diagram. Now look at everyone, look at this diagram. There is a small switch, a small battery, and look at here, the concept is slightly tricky, so everyone has to pay attention here. There is an electromagnet. When you switch on this circuit, what electromagnet will do? Electromagnet will be magnetized. When this electromagnet is magnetized, will it be able to attract the iron rod? When iron rod comes here, look at this. When iron rod comes here, this device will get the power and this device will get on. Carefully see relay in action. This is relay. This is called a relay. A relay is basically a combination of two circuits. One left hand side one is a low power circuit. Right hand side is a high power circuit. What we do, we use the left hand circuit, low voltage one, to switch the high voltage circuit. The concept is simple to remember. Relay is a switch. Relay is a switch. Yes. Okay. Now, after copying the after giving the heading, you had this definition, and now copy this circuit. Copy this circuit neatly. Inshallah. But do it right now. You're sitting here, so you should follow. Mushkil, hardly just like 10 minutes are remaining, so just like manage it. It's very difficult to see a lecture on YouTube. No? Okay, right under it. When the switch S is closed, when the switch S is closed, the electromagnet is energized. When the switch S is closed, the electromagnet is energized. It pulls the iron rod. It pulls the iron rod. This start up the device. This start up the device. This start up the device. So relay is an advantage. It actually give us a gap and we can overcome the gap and we can record, we can move, we can control a circuit. We can control a circuit directly. Okay, now give a gap of 2 lines. A very important topic comes here. Again, this topic is connected. Whenever O level comes, I tell you that this is O level connection. Why I'm telling that? So you people can push up your memory and you should try to reconnect, because memory recall means a big recovery. Force between current carrying conductor, a very important between current carrying conductors. Ahmed. Now look at this idea. Rule number 1. Like currents attract each other. Give the title. Like currents. Rule number 1. Copy rule number 1. Rule number 1. Like currents attract each other. What's the meaning of like currents? Currents in the
Same direction.
Currents in the same direction. Look at this, our memory, and let's see how much we can get it back quickly. The 2 wires are having currents. The 2 currents are both upward. Look at the diagram. Both currents are upward. Now look at this. Current is upward. Current is upward. What type of force between them? The 2 wires will be even possible that they bend inwards. Now we have the idea. What's the theme? Rule number 1. Like currents attract each other. So the 2 currents are both upward or both downward. So now you have to copy this diagram. Make sure, look at the screen, please. Make sure you draw the 2 arrows equal. What's the problem if I make one arrow big, one arrow small? Magnitude will change. Very good. Is it like Newton's third law that the 2 arrows should be equal? This is our Uncle Newton's third law. Ahmed. Now, please look at the screen. Putting my next concept. Can you people notice the amount of current in one wire is 4 ampere, and observe the current amount in the second wire is, but still the two forces are equal. How this is possible? This is according to Newton's third law. So write under it that the two forces are equal according to Newton's third law. Write under it, the two forces are equal according to Newton's third law. Now, I'm putting my last towards the last concept of my lecture today. Now, can you see the two wires are having currents in upward direction? So, both the circular fields, are they pointing in the same direction? They both are anti-clockwise. So, if I move this arrow, I will get north here, north here. So, in a pair, north is faced by south. North is faced by south. As a result, north-south attraction, the two wires attract each other, and as a consequence, the two fields merge. The two wires produce same field, so they merge to form a common field. So right under it, we are towards the end of this concept today. Right under it, the two magnetic fields would be in the same direction. The two magnetic fields would be in the same direction. The two magnetic fields will be in the same direction in the same direction. So the two fields merge. So the two fields merge. So now copy this diagram neatly. The two fields merge. So the two fields merge. जल्दी जल्दी प्लीज कोई अहमद the two fields merge, and this is the front view. Draw the lines neatly. Now, this is the front view. This is the front view. Now look at the last diagram for today. It is just like someone is looking at you with anger. This diagram is the top view. Look at the top view. From the top, if you see the two wires, they are producing, both are dot. Leave the mobile. The two wires are having the current in the same direction. This is the top view of the two wires. So you have to copy this. This is the top view for the two wires carrying current in the same direction. Both are dot. First you were choking and making funny things, and then should copy it instead of just photographing it. Now look at this. This is the last thing for today, and this is the top view. I repeat the concept. I repeat the last concept for today. Like currents attract each other. Why? Because the two fields merge. I repeat, like currents attract each other. Why? Because the two magnetic fields merge together. So we are stopping here.